Hello, my name is Corinna Abesser. I'm the Geothermal Energy Team Leader at the British Geological Survey. And my team is interested in looking at how we can use energy and heat stored in the ground to power and heat our homes. Now, when I speak to people about my work and I tell them that I'm looking into the geothermal potential in the UK, they're quite often surprised because they generally associate geothermal energy with volcanoes in Iceland or hot springs in New Zealand. You don't actually need a volcano, you don't even need to drill a very deep hole, because there is a much shallower, lower temperature source available in the UK and very near the surface. This source is called ground heat or ground source heat. And while we're calling it sort of shallow geothermal, the actual source of the heat is the sun. So when the sun is shining, some of the solar radiation is transferred into the ground and stored there as thermal energy or heat. Some of this heat is lost from the ground in winter when the air temperatures are cooler. But the insulating properties of the soil and rocks are such that a lot of the heat actually remains in the ground. And as a result of this, the ground beneath our feet has actually quite a constant temperature of about 10 to 12 degrees, irrespective of what the air temperature is or what the season is. And it's that constant temperature and the storage properties of the ground that we can use for our heating. Now, how does this work? How can we actually get the heat out of the ground and into our houses? And how can we use something that has a temperature of 12 degrees to heat our homes, which most of us would like to have a little bit warmer? My colleague Humphrey has built a very simplified heat pump system, which he will use to demonstrate how these ground source heat pump systems can work.
So if you see a ground source heat pump in real life, it'll be a big white box with pipes emerging and flashing lights and a control panel, and it's very hard to really understand what's going on. So I've stripped this back and down to its basic components. This is called the evaporator. Now this represents a huge network of pipes buried in the ground, probably in your garden. It absorbs energy from the ground, from beneath your garden, and that energy changes the liquid to a vapour. So as it comes out of this unit, it's a cold vapour. So it's then moves along this part of the system, so through this pipe, and it reaches the pump. The pump grabs that vapour, that gas, and it compresses it, and it also heats it at the same time. So we've now got hot gas making its way through this pipe here, along this pipe, and it reaches this part of the system. Now we call this a condenser, but what this represents is the radiators in your house. So as the hot gas passes through this part of the system, the heat from that gas is radiated into your house. So basically this is where the heat's being used. So this is warming your house. Warm liquid now passing down this part of the system, and it makes its way to this part. Now this is the expansion valve, and as it emerges from the other side of the pinhole, its pressure's dropped, and that takes the energy out of it, and it's turning into it's now a cool liquid. Here we are back at the evaporator, and remember, this represents the system of pipes in your garden. So what we've got is a circuit of fluid which can pick up heat from here, and it can move it from here to here. It can pick it up from the ground, from under your garden, and it can radiate it in your house. And it's all driven by this. So here's the good bit. For every unit of energy required to turn this compressor, 3 times that energy can be transferred from the garden to the house. and really makes quite a good, efficient way of heating your house. So Corinna and I have been pedalling this machine for about half an hour now, and there are some definite changes. This part, the evaporator, feels noticeably colder to touch, and remember that represents pipes in the ground, so that's taking heat away from its immediate environment. This bit, the condenser, which represents the radiators in your house, has got definitely a little bit warmer. When we started it was on 22 centigrade, now it's reading 26 on the indicator here, and I think with the thermal image it should be possible to see a definite contrast between this part and this part. So I think we can say that the experiment has been a success.
Humphrey has demonstrated that we can extract heat from the air to heat a radiator. By analogy, we can use the same process to extract heat from the ground. It's actually replenished by the sun in the summer every year. This makes ground heat a reliable and renewable resource that we can use for heating our homes now and in the future.